Well, well, it is 12 o'clock, so good afternoon, and the trickle of people coming in through the door is slowing, so let's begin. My name is Jonathan Adamczewski, and I am a lead on the Insomniac Games core team in Los Angeles. Previously, I grew up, lived, was educated in Tasmania, and I've been at Insomniac for 6 years now. I worked on Sunset Overdrive, Ratchet & Clank for PlayStation 4. We've been responsible for some Oculus virtual reality titles, and we have a Spider-Man game in the works. Within the core team, my group's responsibilities cover a lot around the areas of performance, of memory usage, of streaming and I/O in general, and packaging of the games that we work on. So turning a game that's in development into a game in a box that can be delivered. But we're not actually on the game team. So the agenda we have is not just to help one team ship one game. It's about building tools and establishing processes that help all our game teams now and in the future to ship their games. And my talk today comes out of that experience, that focus. I will be talking about working on that larger team, working with hundreds of other developers who are trying to make video games. And so it's a complex environment. There's a lot of different people working on a lot of different things. There's a lot of moving parts. It's often, at times, it can take days before you can see individual pieces of work from around the studio coming together into a single version of the game that has all the different moving parts in a state that people are happy with. So we have challenges when it comes to building content that is shippable, that meets the quality bar that we're aspiring to and meets the performance bar that we're aspiring to and satisfies the requirements of the platform, the creative direction of the game, and other standards like, is it fun? So I'm not going to be able to give a full picture of absolutely everything in this setting, not least I have limited time, and it's very complicated. There's a lot going on. Also, I'm covered by NDA issues and things like that, but I'm very happy to talk more about the things that I'm covering today separately. I will be around at GCAP for the next 2 days. Please come and say hi. Tell me what you thought about this presentation. Give me your honest feedback. I would love to hear it. If you've got any feedback on how I could make it better for the future, I would very much appreciate that. I am curious to know of the people here. I'd love a show of hands for some different, experience that people have in game development. So if you're part of a small team, would you, and by your own assessment, if your team is small. If your team is not small, okay. Programmers or other technically minded folks? Yeah, well, there's quite a few there. Content creators, and I'd include artists, designers. And I suspect that the small team means there's some overlap in roles that come with that. Anyone in QA or support? Yeah, a few hands. Much respect for you folk. Management side of things, PM, producers, directors, leads, yeah, a few hands, fantastic. Students, great to see you. So, all right, there is a real mix of people here. Like I said, I'm going to be talking from my own experience. I hope there is something of interest to you in that. As I said, please send me your questions. So, in a small team, responsibility for the product that you're making lies with a smaller group of people. And it means that some things are easier in a small team. Some things can be easier, like communication. It's not easy. I'd say it's never easy, but it's easier in a small team. Design is easier. Decision making is easier. Evaluation of what it is you're making is easier. Prioritization is easier. These things get harder as the team size gets larger, and so require effort and attention to do well, particularly as the group grows. So I'm going to cover a few upfront assumptions that are sort of weigh on my mind as I approach the topic of making shippable content. One of them is that we're actually trying to make a shippable game. Not every team is actually trying to make a shippable game. There are hobby projects. There are efforts that involve prototyping. We're trying to make a proof of concept. It's not actually something that we expect to put in a box, but it's an idea, a foreshadowing of something more. Even as part of production of something that is intended to be shippable, we might be making unshippable content for entirely valid reasons. Again, prototyping of missions, or setting visual quality targets or concept work to say, what could we do? If there was no limit, how far could we push this? We dial everything to 11. So it's worth being aware of. We're talking about the shippable content that goes into a shippable game as the thing to focus on. And there's a whole communication problem space that goes with letting your peers know that some particular part of the game isn't actually, like, the frame rate's not important for this, the memory footprint's not important for this, because it's not trying to be that shippable piece. Another assumption is we don't want to have to redo work. There's an efficiency goal here. No one really likes to go back and have to tear everything down and rebuild it from scratch to achieve a different set of constraints than they had up front. Another assumption is we want to avoid having to make cuts. Now, I can say cuts are always tough, but personally, I can understand a cut of some part of a game, some system, some mission, based on a creative direction decision or just a usability testing decision. This, it's not fun, or it doesn't fit into the bigger picture of this game, and it is fun, but we can't make it work. I can understand that. It's frustrating when it happens. But for something to be cut for the reason that it just doesn't run well enough and we don't have time to fix it, feels really arbitrary and frustrating and embittering as a thing to have happen. So we want to avoid that as best we can. So with those assumptions stated, I want to move on to a process that I believe helps to bring about shippable content, helps a team to work together to make something that is more likely to be closer to what you want to put in the box to get the game out the door. And with many problem-solving techniques, it starts with defining the problem. What is it you're trying to do? And like so many team dynamic problems, it starts with communication. So the defining of requirements is where it begins. If you don't know what it is you're trying to make, how can you get it right? You're not set up for success in that situation. If you don't know what needs to be done, how do you know if you've got there? And that works in terms of not reaching a high enough bar and also exceeding what can be a low bar. We need to optimize this content in some way. I'll just keep optimizing until I can optimize no more. Well, turns out it didn't actually matter. It didn't need that work. That time could have been better spent somewhere else. It's important to define what we can to understand what it is that goes into the game we're making. I would emphasize with this one. So I tend to think in terms of pipelines. So as a core programmer, like I describe myself at times as a plumber of ones and zeros. It's about getting bits from one place to another. And so I think a lot, where did this come from and where is it going and how is it going to get transformed along the way? And this defining of requirements, I think, is one of the most valuable things, and regardless of what part of game development you are working in, this is one of the most valuable uses of your time to understand what it is that needs to be made, to understand the scope of it, to understand the importance of it in the bigger picture, because it's at the start of the pipeline. It helps cut off things that aren't needed. It helps prioritize things that are needed. I could rant about this for a long time, and I've tried very hard not to. So, but what you can do to help establish technical requirements for your project is to ask questions. So if you're on I think it's useful to think in terms of in a larger team, there are often people who are more responsible for decision making, and there are people who are more responsible for implementing the decisions that have been made. But it's important for both of those to understand one another, to communicate well with one another, and to work together. And so for me, I don't set the big picture agenda for the games that the company is making. I am far more on the, we implement what we need to do, but it's important for me to understand what exactly is required. What is this game that we are making? And so there are a lot of questions that you can and should ask when it comes to making a game, and it doesn't matter what size team you have, that help frame, limit, constrain what it is you're making so you can focus on doing the best things. Do you know which platform or platforms you wish to ship on? Do you know how many players there will be? What kind of game will this be? What will be different about this game compared to every other game? What distinguishes this one? What will be different about this compared to other games that we as a company have made before? Who is the target market? What strengths of ours do we expect to leverage to make this game, and what weaknesses are we going to have to attack to be able to achieve it? So that's just the starting point. I can give you hundreds of questions about trying to frame, shape a game. But even something like single versus multiplayer may be something that there isn't a clear answer to at the time early on. You're asking, I don't know yet. We're considering a multiplayer mode, but we haven't decided. Maybe it involves conversations with a publisher, in which case it's very hard to push back and say, well, make them decide, because there's so many other things that is their concern and not mine that they need to work through and decide. What you can do is identify the unknowns. Just listing the unknowns is useful. What is the risk we have to work with? What are the things we have to take into account? You can also ask, is there anything we can do to help answer that question? Can we prototype something? Can we make a proof of concept? Can we just fake some data at a scale that makes sense? Like, we have some multiplayer infrastructure. How many players are we talking about? Let's fake that many clients and see what scales, what breaks, and how much it would cost to build this thing. Defining the requirements is a key part of this whole process. There is the case, you may not know what questions to ask if you're new to a space, if you're stepping into something you don't know. I can say for myself that I have, compared to a number of my coworkers, I have a short history in game development. And so there's been several times where I've come up with something that I think is a fantastic idea. Guys, we should totally do it this way. And the response is, yes, we tried that 3 games ago, and it turned out to have all these problems, and so we cut it and replaced it with what we have now. And I go, aha, all right. I learned something in that process, but I don't know what questions to ask. What I have learned with that is that rather than assuming I'm the smart guy and everyone around me doesn't have any idea, it's important to approach it with the assumption that there is something to learn here. There is something to understand that's bigger than what my perspective is. What have I overlooked? What use case have I not understood? There's a great opportunity to learn in this space. If you don't have coworkers with experience that you can lean on, you can find other more experienced people. We're at GCAP. Find someone who you think might know more about game development and ask them if you can describe your game idea to them, and then see what questions they would have. Ask them to ask you the questions they would ask. There is a resource there. If you don't have contact with other people, or if that's not something you can do, there's still processes you can use as an individual to try to tease out, what is it I don't know? What are the unknown unknowns? You can make a list of all the parts of the game that you've never actually had experience with. What are the things that I think will need to happen to ship this game? Is there a resource online that I can find that helps me understand that? So you can work through to find the questions to ask to build the requirements, build an understanding for your game. So I have a few examples of requirements or problem spaces for this presentation. The first one is, in some ways, seems like one of the simplest things. Frame rate, right? It's just the number of times you update the screen per second, or if you like to do it the other way, it's the number of milliseconds between updates of the screen. Frame rate is one of those things that for many types of games, obviously not all games, but frame rate is important for a large class of games. And it's something that it seems on the surface simple. Like well, we can look at instantaneous frame rate, how long was each frame, or we could average it over a period of time. But it's not enough on its own to know that number. You need to know what is it, what should it be, right? And I want to say that this seems like, maybe, is this too trivial a case? I feel like there's enough just in frame rate that it's worth thinking about as a problem on its own. It's the easy thing, and if we can't do it well, and I have seen it done badly, if we can't do this well, what hope do we have with more complicated, derived concepts in our games? So what do we need to know to be able to decide what the frame rate should be so that we can create a requirement that is precise and clear and measurable? Well, we probably need to know the target platform that we're concerned about with regard to frame rate. We need to know where we want for the player. Are we making a VR game where 90 frames a second is the target we're trying to hit to minimize nausea? Are we making, like, is it a text adventure when we're actually talking about responsiveness to, in how quickly the characters show up? Is there anything else that comes into play here for different platforms? So you get to talk this through. And it can be written then, or at least understood as, a firm, somewhat precise requirement. So maybe something like this. On the minimum spec platform, the game will never drop below 90 frames per second. Like, that seems like something that's measurable. It seems like something that's a plausible goal for a VR title in particular. Or you might have something like this. On the target platform, the game will run at 30 frames per second, but may drop as low as 25 frames per second for up to 2 seconds at a time. Perhaps for the team, the importance of hitting a hard 30 is not so much there. The game is still fun. And, sometimes explosions happen or crates explode and debris flies everywhere. 2 seconds seems long enough for some of that to settle back down and continue on. And while there's a lot of activity on the screen, maybe the frame rate's not important. You make a judgment call about the experience you're committing to for the player. If it's really not important and you don't care, there's still some value in saying something. Is it good enough? Do we agree that it's good enough? You can democratize it as a thing. I don't know that this would scale to a larger team, but the point being there's different ways to express these kinds of requirements to make them something useful to help shape the expectations of what the game will be. So once you have defined something like this, it's not enough just to make a rule and say, and thus the game never went above or went below 30 frames per second. You actually have to do something about it. You have to measure and report. You need to track it and do something, or at least be aware of where things are at. So measuring and reporting with regards to frame rate can take a number of forms. You could put something up on the screen, a number, a single number that reports an instantaneous frame rate. You could put it something that's an average. You could have two numbers, which is both. I find that as soon as you put more than one number next to one another, it can be confusing to less technically minded folks. It's helpful to have something concrete that you can point to and say, this is the one thing you need to worry about. You can go quite a bit further, and so a single number can make it hard to detect patterns over time. You can do something. So this is from a title that I have worked on in the past, and it represents essentially an encoding of the policy that existed for that title. That we would show the frame time, the CPU time, the GPU time as lines on a chart, and then it would flow across from one side to the other as time passed, and the background color would change depending on which space you were in terms of the quality bar we were aiming for. So if it was at 25 frames per second or better for less than 2 seconds, you got the brownie bit. As it's not where it needs to be. It's not shippable, but it's okay while we're prototyping, and it's not a problem. But if it's in the red zone, even if it's just a test level, even if it's a prototype thing, it's not okay. The player experience is impacted to the extent that we can't tell if it's going to be fun the way we want, because we're working on a game that we want the player to be highly reactive. And so we make a choice to say, even in development, this isn't okay, this is something that needs to be attended to. Another example is one of memory usage. So memory is a finite resource, mostly. There's, PC development, you've got virtual memory. At some point, there's more bytes to be had somewhere behind the scenes. But, that comes at a big performance cost. You can expect that to show up in that CPU line on the previous chart if you start getting into that space. Memory usage is an area where there is a finite resource that can be used up. And so it's something that's worth tracking. It's something that's worth having requirements set up for so that you know what is our expectation with regard to memory use. So you could say something like that, and if that's not true, the game ran out of memory sometime, then, well, the requirement hasn't been met and something needs to be done. So that particular phrasing isn't precise enough for my tastes because it doesn't really deal with fragmentation. The game didn't run out of memory, but this allocation, which the heap said there was enough space for, couldn't actually be serviced because the free space was fragmented. So you can refine it and say, like, okay, it didn't run out of memory, but it couldn't allocate it, so it's effectively run out of memory. You can go further than that. But so I wanted to talk a little bit about how we manage memory for our engine and to go on to a consideration that plays into the memory usage case. So at Insomniac, our approach is to account for every allocation the engine makes. And we get to do that because it's our engine and we can instrument anything we want to, I guess. And so every memory allocation is from one of our custom allocators. You pass in a C string with it to name who is allocating the memory. You track it through to be able to see who allocated this memory, where did it come from. We have configuration file that lists for different allocators that we use within the game, the sizes that they will be when the game starts up. And when that configuration is read in, that is compared against the amount of memory available for the game. So on a console platform, that's like all the memory on the console. How much have we asked for? Is there enough for that? And if there is, great, the game can run. If there's not, there's an instant fatal assert right there saying, this cannot be, this cannot run. We break it down into different allocators based on a number of different factors. So for example, we have an asset allocator for game assets, visual effects and shaders and environment art and where it's placed in the world, things like that. And that's the allocations that come out of that heap tend to happen in larger bulk, sort of load and unload phases, say in an open world game or loading in and out of a mission. You have groups of allocations that are allocated and subsequently freed as a thing. So it has a particular pattern to it. The dynamic heap is one where dynamic allocations are made while the game is running. Gameplay objects particularly, things that are short-lived come and go. There's a rapid rate of things being created and destroyed in there, or there can be. It tends to be one that can be a source of problems and performance problems, so that there's a continuous attention to keep some pressure down on that. But we have a different heap for those objects that have that different lifespan. We have a heap for model geometry that's mapped in a way that's efficient for the GPU to access. And we have a different heap for texture data that is again mapped differently for the GPU. It uses a different type of backing heap, one that doesn't fragment at all. So we're able to avoid that particular problem, and we don't need to compact it as the game is running. So there's a performance win, but there's a space trade-off because we have fixed size block allocation in there. There's different heaps for different purposes, and we're very intentional about how we set that up. But what that means, though, is that, well, any one of those heaps can run out, and the game will either not work as expected. The texture heap is a little bit friendly of things just start showing up grey and lacking their distinct colour and style. But the other heaps, if an allocation fails, that is game over, typically. Something's not working the way it should, and the game should stop running. So if we know, this is where we take into account not just the shippable content, but the making of the shippable content, the process that goes into making this game. We're not just talking about the finished product. What we want is a game engine that's robust enough and a game setup that's robust enough to work through the ebbs and flows of the production life cycle. And when say for a particular mission, someone adds a ton of brand new assets and they look amazing, and they're too big to actually be shippable content themselves. If we go from, like, we were right on the edge and now we're out of memory, and no one can do anything in that particular setup, that's a problem. We need to have some headroom in there. We need to have some space. So the analogy I have for this one is, so I roast my own coffee beans. And so if I had a requirement on my pantry that was, I shall not run out of coffee beans, everything's fine until I run out. And if I ignore how much is in there, then I have the risk of, as I pour the last beans into the grinder, I realize, uh-oh, no more coffee, or I get to sample the finest supermarket variety I can get, or there's a problem there until I have time to roast again. The analogy is, for a production team, once something hits an out-of-memory situation, or a failed allocation situation, the production team is stopped until someone can get in there and do something about it, analyze the problem, deal with it, and set it up again so that it's runnable. So instead of saying, we're going to set the requirement on the line, we can set the requirement just a little bit lower. And this also helps to factor in the effects of fragmentation over time. So if we're to say, and 90% here is probably optimistic, we use TLSF for many of our heaps, two-level segregated fit, if that's the kind of thing you are familiar with, look into it, it's fantastic. But it does particularly well for maintaining fragmentation or for minimizing it. But at 90%, the game probably runs just fine. At 90% utilization, the game runs fine. But when it gets greater than that, for extended playthroughs, the risk of fragmentation causing a failed allocation goes up. And the closer you get to that 100%, the higher the risk. And so what we want to do is have checks to say that we want to keep it at a safe level, because it also relates to shipping the game, but we want to keep our production team productive. We want to keep things set up for them to be running well. And so to report this, to go back to the track and report, it's not the word I had, but anyway, side of things. What we have is a view that sits up on the screen, something like this. We have a few other heaps in there, but this is like the simple version, is to say, like, here is where utilization is at right now, and we have a process for our QA team to say, as you play through, if it turns red, that's a bug you should file. So, all right, we've got to defining the problems, we've got to, I guess you could say, pointing the finger, being able to at least monitor what's going on and identify that there's a problem and call it out. The next step is then what happens? Who does that bug get sent to? And another key personnel and process step that helps get this, helps set us up for shippable content is one of assigning responsibility, of having someone who is the point of contact for this class of problem. Without someone having responsibility, it's easy for it to fall through the cracks. In a smaller team, you can have a culture of everyone is responsible for a thing, and it's easier to maintain that. You have enough influence with one another to pull that off. In a larger team, something that's everybody's responsibility can become nobody's responsibility, because it doesn't scale with the number of people. If someone checks in a change that causes a problem and 15 people all independently say, no, it's our policy that we're going to investigate this, or we're going to report it and see who's already doing it, it's a waste of time. It's better to have one person who is the channel through which that handling takes place. What you want, though, for that person with responsibility is a sense of authority for them. They need to be able to talk to the stakeholders and say, there is a problem here that we need to deal with. They can talk to the creative director and say, you can't have all the enemies and all the bosses and all the heroes all at once in the one location in the game. We just don't have the memory for it. At least not with the assets we have. And so it starts a conversation about, well, what could we do? Can we use a different LOD? Can we do a different version of the assets? Can we pre-bake something? There's ways to solve the problems to achieve a creative vision, probably, but it needs to start with what we are trying to do right now is not working. The role also needs an accountability to know that when this problem persists, that someone can come back to them and say, what's happening with that? That they're aware of it, they're responsible for it, and they're doing something about it. And it should have clear expectations. The person who has responsibility as, you could say, first responder, is not necessarily the person who's responsible for fixing the bug or fixing the problem. They're not necessarily, they're rarely the best person to solve it, but they know the path to the best person. They know the next steps. They know how to route things. They know how to say, if it's, so it's an acid heaps over, I know who should look at that next to dig in and to understand. And that leads on to the next point. Need to be able to answer why this thing is happening, why this requirement has not been met, and then to find who should do something about it. It's that passing on of responsibility to ensure that things get dealt with. As a programmer, it's really easy to think that once you have implemented a system, it's done. My job is done. It runs, it works well, on to the next thing. A day of successes. As an engineer, building systems used by others, which content that probably comes from a range of different sources, it's not good enough to say, here is your system that can process foo widgets at 70,000 per frame. What you need is tools for the users to reason about how that system is being used, what's going into it, what it's working on, and why it's failing. The process of analysis and review is critical in a large, complicated system to be able to feed back to users so that they can diagnose problems on their own. If you as a programmer have put yourself in a position where it's always up to you to dig in and tell someone what's gone wrong, I guess there's some job security in that perhaps, but it's not sustainable. And particularly if you're spending a lot of time in one organization, there's limits to that. You can't keep building things and expect to be the one central focal point for all of them. All of us are limited human beings. We have limited capacity. We are better off, as engineers, setting things up to help our users use our systems well and to understand them. And so the heap percentages is one version of a first initial inspection tool for something like that. If we look at something like this, if you were to look at that and say, okay, this has come up on the screen because the GPU's running kind of slow, it should hopefully be clear which department you would go to first to talk to about the problem. I'm going to say, the lighting department, right? It's red, the biggest number, and the bottom line is also red. And we know, say we're trying to ship a 33 millisecond per frame game. So it should be clear what the next step is. Now, we have something like this view in our engine, and it's a source of some convenience and some frustration. And I'd say it doesn't need to be perfect to be useful, but there's a balance with that. There's obviously a cost of things that get routed imperfectly. So, for example, VFX, in our engine, it's difficult to decouple the rendering of visual effects with alpha blending, from other things with alpha blending, because the way they get submitted to the GPU and the cost of trying to separate them back out can be relatively high. And so what can happen is that things will show up as a VFX is running along that turns out there's just an awful lot of glass layered over other glass in a particular scene. So it's not we have tools like this that aren't perfect, but they're still useful. They're still very useful. And once you have assigned responsibility to, say, a VFX artist, they're also capable of very quickly saying, this is not a VFX bug. Like, there's a screenshot, the VFX number is high, nothing's exploding, there's no water, there's no effects in this scene. There's a good chance it's that glass there. So helping to get it to a knowledgeable person in the problem domain is a useful step still. Very much, though, goes to responsibility and accountability. A bug assigned to one person, that is a concrete, trackable thing. So the next example, the final example for this presentation, is open world streaming. And we've worked on a few games that involve an open world environment, a fairly fast-moving hero character, fair amount of, a lot of detail, baked lighting data, many things coming together. And it's very easy in an environment like this for artists to build something that is not shippable. It's very easy to pack a lot of detail into a small part of the world, which the player may spend a lot of time inside of and be able to see and enjoy all that wonderful detail, but it's not actually shippable content because it's not sized in a way that we can get onto the disk or we can get back off the disk fast enough. So, and I would make the comment, as we have iterated on our own editor tools and as we have adopted some procedural techniques for content generation, it's become easier and easier to create unshippable content faster than ever. So it's clearly a problem we have wanted to try to stay ahead of and to avoid. So in Sunset Overdrive, the city was laid out as a series of hexagons, a series of hexagonal tiles that would be loaded in based on the player's distance to those tiles. And so as the player moved through the level, things would be loaded in on demand as they moved. Now, when you're making that kind of game, and what I can say for Sunset Overdrive was made for a specific platform. So we had some guarantees about the capabilities of that platform. We could say we know how fast the hard drive is. We know how quickly we can get data into memory. We know other things about loading that. And we also know, because this is our game and because we can ask the question of the game designers and the gameplay programmers, what's the maximum sustained speed of the hero? And with that information, this problem, I really love this problem because it becomes one of fundamental physical limits. It's like, I can genuinely say, I can't change the laws of physics. The hard drive only operates this fast. And so we can there we go. I missed that slide. So we could have a requirement like this. On the target hardware, the player will never see a load spinner nor fall through the ground, which is the failure case for something like this if the player moves faster than it can load. We can get to this, where we can create a function, essentially, that takes the hard disk throughput, the hero speed, the tile load distance, and gives you a number of each tile cannot be larger than this size, or we absolutely cannot load it into memory, even in the best possible situation, right? This is my favorite. It's great to be able to reduce it to this. The challenge then is in turning it into something that helps our content creators actually build levels that fit those constraints. Because this is a detail that particularly the hard disk throughput or the size on disk really is not something they have first order direct control over. They do things that affect it, but I just placed some more of these models. Were they already in there? If they were, we use an instancing system, so you don't pay extra for the geometry that you're adding. So it's very cheap to add more of the same. But if you add something new that's not used, or you add something that was previously used and someone else takes it out and replaces it with something else, there's plenty of cases where the size can balloon for surprising to the artist reasons, because it's an opaque system for them to work with. So what we have sought to do is build a system that helps them to reason about that as a tool to build that shippable content first time round. So anyway, you can take that game experience requirement and you can turn it into a concrete, precise, measurable requirement in this case. And X is whatever the size is for the game you happen to be working on. So this is something that we turned into, we've gone through several iterations, several generations of tools for helping our artists work with this problem. The first few were, frankly, terrible. The package build step, which ran on an automated system twice a day, this is the first version, would spit out a report saying the size of all the tiles in the game. And so it was a HTML report, and someone would have to open up a browser and find, remember where they'd stored the link and click it and go and look through and say, do any of my tiles, are they over budget? Do I have to do anything about it? No one, as a regular course of action, looked to check to see if that was a problem, because it wasn't important to them, and it was really awkward for them to try to do, and rightly so. The next approach we took was to build a separate tool that at least lets you inspect a specific tile to gather the data in and give you a bottom line size for that. But even that was an extra external step. It was outside of their regular workflow, and it was something that you could only look at one tile at a time. It was kind of clumsy. It didn't get a lot of traction. What we've been able to do this year is turn this into a system where it's integrated directly into our level editor. We have added the logic that's used in the packaging system into the level editor so that it, when it starts up, is able to compute the sizes of all the tiles in the level at once and give you a report. And screenshots of spreadsheets I find kind of dull, so I didn't bother. But really, it's a list of tiles and a list of sizes, and you can sort them and see which ones are over budget. And this, it seems like that's not an innovation as a thing. But the steps involved in simplifying it down to what are the key pieces of information and where does it need to be for the artist to make use of it. And we have seen a huge increase in their level of interest in it because it's right there available to them, and they can get direct feedback. They can make changes and see those numbers change in real time. The one sticking point we had was that doing so still required every artist to pay attention to that, and it's not always relevant all the time to them. And so any process which you kind of have to remember to do and remember to click the thing and check if there's a problem, it's not a good process. Basically, people are going to forget. People are going to choose to forget. It's not something that, as tools developers, we want our users to have to do. So what would happen is environment leads would instead, they would look at the report and they would try to break down the results for the members of the team. And even that was kind of inconvenient because they'd still have to look at the tile and say, so, this T37, was that, which person was that? Like trying to maintain all the different combinations and map it directly to a user in your head was a bit much. So we went through a surprisingly convoluted process to come up with the solution to the problem to solve that and make it easy to work with, was to add another column which had the name of the artist in there. So we put the owner of the art right there in the tool. Now, from the core team perspective, I can say I understand why we didn't get to that quickly, because we don't think in terms of building tools for specific assignments of people to roles on a given project. I said at the start, we're thinking about multiple games. We're thinking about building systems that are bigger than any one game. And so the idea of saying that specific artist for this specific piece of content right there in the tool, that was an unusual concept for us and not something that we've done a lot of. It turns out it's really easy to do. Put a CSV file in Perforce that the artists themselves can edit and that has a list of tile names and usernames, and when you show that particular view, look in that file and work out if the tile has an owner. It's simple logic, it's simple data to manage, and it's been amazingly effective. There's regular reports going out where artists are named and identified as needing to give attention to the parts of the game that need attention. And it's made a huge difference. And this is the most encouraging thing. The effort we've put into building this tool and getting it into a state where it's easy to use, it's readily available, and it does what our artists want it to do, has made a huge difference to the tiles that we have that are in budget. We now have shippable content where before we did not. And that's exciting to me. The other thing, being able to put those numbers in front of the content creators does is lets them stop when they are done, when they have done enough work. When there is no more required, they can stop. And this is, I think there's an important psychological benefit that you can think of with this as well, is that sense of achievement to know, yes, it was over by, it was over by 30%, but now it's shippable again. I can tick that off, I can cross that off, I can close that bug, whatever it is, you get that sense of achievement, of progress, of knowing I've taken this from unshippable to shippable. And you get the same feedback to say, I've made this thing and it is in fact shippable and I don't need to make any other changes to it. I know it's where it needs to be and I don't have to worry about it anymore. That's an advantage when making content at that scale. And on the topic of stopping when you are done, allow me to sum up. So there's a lot of people and process involved in doing this well, in building shippable content. Requirements is about communicating, is about asking questions, is about understanding. is about trying to plan to solve problems. Measuring and reporting and the answer why and find who part of the problem is about putting good, actionable, useful data in the hands of the people who will need to solve the problems. Assigning responsibility is a process step, again, is about recognizing that if someone is responsible, there is a greater motivation for getting something done. And stop when you are done, again, there's a people focus in that as well, the sense of achievement, the sense of good. So many of the problems in game development have nothing to do with writing code. They have a lot to do with working well as a team, scaling well, being healthy, planning well. I would encourage you to focus on that side of things particularly. And with that, stop when you are done. I am done. I do have a slide to say thank you to Film Victoria, who have sponsored my attendance here through the International Speaker Program. And at that point, I would ask if there are any questions. Thank you. Yeah.
Do you experiment with automation by emails or perhaps like generating bug reports automatically?
I don't think we've gone as far as generating bug reports automatically. We've definitely experimented a lot with automated emails, and I feel like I could do a whole separate talk on the pitfalls and difficulties in doing those well. It's really easy to bury someone in a wall of slightly inaccurate emails that don't actually help get anything done. Emails as well, I think, don't touch on the accountability side of things themselves, because just because I've received a bunch of emails, like a machine says that something needs to be solved, rather than there is something in the process and the steps. So I think my current favored position on automation is that to go to, say, project managers or leads to say this is the current state of things, and then to let them act in a way that is more appropriately targeted. Maybe I just don't believe enough in our own ability to write sort of AI systems for that part of the process. Yeah.
Do you have any tips for small teams for the trade-off between writing tools and making things simpler for the person actually?
I will try to repeat the question. I think I forgot that over here. Do I have any tips for small teams in terms of trading off tools to make it easier to analyze versus actually making the content? I think I got that right. I think that there's absolutely, it's very easy to fall too far one way or the other. It's very easy to say we're not doing any tools for anything and everyone's just going to do it the hardest possible way because we just want to get that content done. And it's very easy to go the other way of, no, this one thing will totally change everything this time. And the reality is that somewhere in the middle, there are problems that are worth automating, there are problems that are worth building special analysis tools for, and there are problems that are not. I think, so a rule of thumb that my department head has impressed upon me, that I fall back to, is rules of three. If I build this thing, what are 3 significant differences it will make? That one on its own is not enough. Like, I can build a tool to make this thing faster. If I can build a tool to make 3 things faster, that's a more compelling case to say that there's probably scalability benefits that go beyond this. And if it's 4 different classes of thing, that's almost a guaranteed yes, let's do that.
I was just wondering if Insomniac uses the agile project management structure, and if you do, how do you incorporate that into measuring and reporting?
The question was, does Insomniac use an agile project management structure? And if so, how we incorporate that into these processes? We don't at a whole company level. Individual groups use aspects of agile techniques. We have some groups who specifically do daily stand-ups, and it's the structure of the company means that there's not one central technique that applies there. And so as a result, this is a presentation that comes from that context, I guess, where there's, I think, company-wide structure applied to our processes would be a good thing, whether it's agile or something else. But definitely greater structure in what we do, I think would be advantageous. Any other questions? All right, well, thank you very much for your time, for your participation in this talk. Enjoy the rest of GCAP.